In this video, I want to treat enthalpy change. Enthalpy simply means heat content of a reaction, the total heat content. Now, when we say enthalpy change, it means change in the heat present in a given reaction. So, the change in the enthalpy of the given reaction is called heat of reaction. And the enthalpy change of any reaction can be found using the approach enthalpy change of the product minus enthalpy change of the reactant. That is subtracting the enthalpy change of the reactant from the enthalpy change of the product. This sign here represents standard value. Therefore, every enthalpy change here is in standard. Another point you need to know to understand this topic is that standard enthalpy change is always in per mole of the substance. 1 mole of that substance is always involved in standard enthalpy change. Now, let's have a look at this question. We are given this information. We have to find the standard enthalpy of formation of gaseous butane, which is C4H10, and we are asked to find the type of reaction that occurs, and we give reason. Let me pause the video while you give it a try. According to this reaction, this is the combustion of butane. When butane undergoes combustion, 1 mole of butane undergoes combustion in oxygen. It produces 4 moles of carbon dioxide and 5 moles of gaseous water. Now, this is the product side, and this is the reactant side. So now I want to find the sum of the enthalpy change for the product. That is delta H. That will be the addition of delta H of CO2 plus delta H of H2O. So I'm going to add the two together. So let's do that. And since this is 4, that will be 4 into, then what we are given for the enthalpy change for 1 mole of carbon dioxide. We have to check it. For 1 mole of carbon dioxide is -393. This negative means it's endothermic. And since we have 4 moles of it, we multiply by 4. For 1 mole of gaseous water is -285 kilojoules. But because we have 5 moles of it, we multiply by 5. So let's sum everything together and see what we get. The total enthalpy change for the product side, which is this, is -2,907 kilojoules. Now, the whole reaction is called combustion reaction of butane. That means the enthalpy change for the combustion reaction is equal to that of the product minus that of the reactant. So what are we given for the enthalpy change for the combustion of butane? According to the information we have in the question. Yes, the enthalpy change for standard heat of combustion of butane as given in the question is -2,874. So minus 2,874 is equal to, for the product, which is this, minus 2,997. Then minus, how do we now get for the reactant? This is the reactant side. That will now be, for the C4H10, enthalpy change for C4H10 plus that of 13/2 of oxygen. But because of the fact that oxygen does not have any formation, heat of formation, so that will be 0. This will be 0. That means we have the formation of this left. So, and this is what we are looking for. So definitely that would be minus 2,874 is equal to minus 2,997 minus delta H, standard delta H for C4H10. That is formation of butane that we are looking for. So by the time you cross this to the other side, then what will that give us? The standard enthalpy change for the formation of butane is negative 123 kilojoule per mole. Remember, I told you anything standard is per mole. And don't forget here, for the oxygen here, its enthalpy change is 0 because there is no formation of oxygen or any information given about formation of oxygen. So that is why it is 0. Supposing we are given, it will be included in the calculation. Now, to now answer the second question, that what type of reaction is this? The reaction is exothermic. Why? The reason is that the enthalpy change of formation of butane is negative. If the answer was positive, it would have been endothermic. So take note of that.